Okay, let's dive right into this because this is one of those technological shifts that honestly sounds like pure science fiction, but it is happening right now. Major U.S. cities, we're talking New Orleans, Atlanta, Seattle, are currently actively routing emergency 911 calls to artificial intelligence agents. Now, if your immediate reaction is a spike in your heart rate, you are absolutely not alone. Handing over life and death emergencies to a machine feels incredibly unsettling for sure. But the reality of exactly why this is happening and how it actually works is absolutely fascinating.
I totally get that the immediate robot phobia is real, but in this explainer, we're going to look past the fear and rely on the data. We'll be covering the 9/11 system crisis, how AI triage works, hallucinations and voice errors, security, swatting, and bias, the liability question, and finally, mitigating total risk.
Starting off with Section 1, the 911 system crisis, a system breaking down.
You know, whenever we discuss implementing AI, we kind of just assume it's replacing this flawless human system. But experts actually describe our current 911 network as a severely underfunded dumpster fire. To really understand why, just look at this number: 50 to 60 hours. That represents the mandatory weekly overtime that exhausted human dispatchers are being forced to work right now just to keep the lights on. Because these departments are so massively understaffed, you've got these drained employees sitting in chairs, dealing with literally the most horrific moments of people's lives, making split-second life-or-death decisions under incredible, unrelenting stress.
We all expect this ideal system, right? You call, someone answers instantly, help arrives in 5 minutes. But the current reality is extreme response times and massive systemic overload. Just look at the catastrophic flooding from Hurricane Helene in Asheville. The 911 system was so completely overwhelmed that the public was told not to call unless it was a quote-unquote real emergency. Think about the danger of that kind of self-triage. If you're having chest pains but you look out the window and see your neighbor's house has collapsed, you might just hang up the phone, assuming their emergency is bigger than yours. Because the system was fundamentally broken, a lot of people just suffered in silence.
Let's move to Section 2, how AI triage works, managing the search.
So the goal isn't for AI to handle every single emergency from start to finish. Instead, it's meant to act as a highly efficient triage system to prioritize calls during sudden massive surges. Let's break down exactly how that works in practice. Imagine a massive car crash on a busy highway. Suddenly, 10 different people dial 911 at the exact same time. The AI instantly detects the geographic overlap of those 10 incoming calls. It routes them to a virtual agent which asks a really simple question: are you calling to report the car crash on Highway 9? If a caller says yes, the AI gives them an update that emergency services are already on the way and then safely ends the call. But if the caller says no, meaning they're calling about an entirely separate, unrelated emergency nearby, the AI instantly routes them to a human operator. By skimming off those duplicate calls, it takes immense pressure off the human team.
And this brilliantly illustrates exactly how we keep the AI from just going rogue. We aren't just plugging in a large language model and asking it to guess what to do. Nope. Instead, developers build a hard-coded database of triggers and actions. If the AI hears triggers for a medical incident like heart pain, the strict hard-coded action is to dispatch an ambulance immediately. If it hears a complaint about a barking dog, the hard-coded action is to put that in a low-priority queue. By locking down these specific workflows, the heavy lifting is completely removed from the AI model, which drastically reduces the chances of it just making something up.
All right, Section 3, hallucinations and voice errors, the tech flaws.
Let's not pretend this is a flawless fix, because emergencies do not happen in quiet, soundproof rooms. They happen in absolute chaos. Just look at the data from a February 2024 NewsGuard study. It found that even advanced frontier chatbots produced false claims, or hallucinations, about 50% of the time when tested on realistic audio. 50%. Now factor in the severe friction of a panicked caller screaming through low-bandwidth, compressed cell audio with sirens blaring in the background. If a voice model misinterprets an address or the severity of an injury in that kind of environment, the consequences are obviously catastrophic.
So, how do these systems prevent a total disaster? With a mathematical failsafe. While processing a call, the AI is constantly generating an internal confidence score regarding how well it understands the situation. If that confidence score drops to 80% or lower, maybe because of bad audio, confusing answers, or an unrecognized scenario, it just stops trying to process the call and immediately flips the caller over to a human operator.
Moving on to Section 4, security, swatting, and bias.
When looking at the tech itself, we know past algorithms have had some serious built-in blind spots. Remember early automated soap dispensers failing to recognize darker skin tones just because of narrow testing data? If that kind of algorithmic blindness makes its way into an AI deciding who gets an ambulance first, the results would be devastating. But interestingly, AI might actually improve safety in other complex areas, specifically through a process called semantic analysis. This is where the AI analyzes not just the literal words being spoken, but the emotional level and the hidden intent behind the conversation. Right now, human dispatchers fall victim to swatting, those malicious, fake calls designed to send an armed police response to an innocent person's house. An AI using semantic analysis could cross-reference the caller's tone and phrasing against a massive database, detect, say, an 80% similarity to past swatting hoaxes, and warn responding officers that they might be walking into a fake scenario. That could literally save lives.
We also really have to look at the defense against cyber attacks. A common threat is a malicious denial of service, or DDoS attack, where bad actors flood a 911 center with automated spam calls. A typical dispatch room might only have, 20 human operators? Once those 20 lines are busy, the entire system crashes and drops all other calls. Compare that to a cloud-based AI system. It can effortlessly handle 10,000 concurrent calls at the exact same time. It is vastly superior at absorbing and neutralizing digital attacks that would easily overwhelm our current human infrastructure.
Next up, Section 5, the liability question. Who takes the blame?
On paper, running an AI system on a platform like 11 Labs might only cost about $1 per call. Compare that to the massive budgets required for unionized human salaries and pensions, and you can instantly see why city governments are so eager to make the switch. But implementing technology at a municipal level is rarely cheap or efficient. Just look at this staggering number, $500 million. California attempted to implement a next-generation 911 system a few years ago. Because of the notorious idiocy of government contracting, they wasted $500 million over 10 years before scrapping the entire contract because it was totally worthless. So the true cost of deploying AI safely could eclipse the projected savings very, very quickly.
And that brings us to this stark, terrifying question. Who takes the blame? When a human dispatcher working a 60-hour week makes a mistake under pressure, our society and our legal system generally have compassion for them. We understand human error. But our legal system is entirely unprepared for a machine making a fatal logic error. If a coder in Silicon Valley accidentally hard codes a fatal triage mistake into the workflow, and someone dies because the AI followed that bad logic, who goes to prison? We currently do not have the legal frameworks to assign liability in these specific AI emergency scenarios.
Finally, Section 6, mitigating total risk.
So, the absolutely crucial point here is this. We have to fundamentally adjust how we view safety. When evaluating this technology, we cannot hold it to a standard of absolute perfection, because no system, human or machine, will ever be perfect. The source material for our explainer today presented this incredibly hard, uncomfortable truth. Quote, if we have humans answering the phones, people are going to die horribly. If we have computers answering, people are going to die horribly. The goal of implementing AI into the 911 network isn't about entirely eradicating risk. That is literally impossible. The goal is mitigating the total amount of damage done in our communities. Which leaves us with this final provocative question to consider. As cities like New Orleans, Atlanta, and Seattle roll out this tech, we have to look past our innate fear of machines. We have to weigh the ethical terrors and technological flaws of AI against the failing, overloaded reality of our current human-run dispatch centers. Ultimately, will these AI systems lead to fewer horrible outcomes than the broken system we currently have? The answer to that question will determine the future of emergency response in this country. Thanks so much for joining me on this explainer, and I hope this gives you a much clearer picture of the complex reality unfolding right now.